Hey there, welcome. I'm not in the garage today, but I thought I'd give you a little update on what I've been playing around with. Uh, just been getting into DCC-EX, so if I point my camera over here on my messy desk, there is an Arduino Mega with a motor shield on top of it. It's plugged in, powered on. You can see the little LED there. And what I've been fiddling with is I want to use that for my programming track, so it'll be able to do my programming, and I've got a loop of trap set up so I can run it around, run a train around, and when I do a DCC install, I can run it around and break it in a little bit, get it warmed up. But I wanted to add something to some sensors to that to allow me to do speed matching. So I need a speedometer. Um, there's a couple ways, different ways you can do it. You can add, if I go here to my sensor screen, let me bring that over here for a minute. Whoops, that's my spreadsheet. If you go to my sensor screen, DS1 and DS2 are pins actually on the Arduino Mega board. And I could use those with these sensors directly. If you watch, you see the green light means I've got power, but the secondary light that comes on as I put my finger in front of it, that is it detecting. Okay? The problem with that is that if you use the speedometer that's in JMRI, it'll only detect in one direction, meaning you can have sensor 1 starts the timer on entry, and then I could set up sensor 2 to stop the timer on entry, and it would calculate the speed. And then the third sensor box here is designed for a further reading for faster speeds. However, what I found is these little sensors are only, bring out the tape measure here, basically 2 inches apart from each other. I don't know if you can see that in the screen, but they're 2 inches apart, which works out to 26.6 scale feet. And let me reset this, figure out which one detected. If I wave my finger in front of this, that's 362 miles an hour. Fastest I can get it to detect is like 642 miles an hour. If your trains are going that fast, I don't know what you're doing, but even the Shinjin, the hyperspeed Japanese train, doesn't go that fast, I don't think. But so 2 inches is a decent size, or 2 inch spacing is a decent size to fit inside of an N scale building, which is what I model. So basically, what I did was I added this Arduino Nano, and it's running a sketch that turns this into a latching sensor. So right now you can see the little red light flashing. That means it's waiting for one of these two sensors to trigger. And if I trigger that, now that lights on means it's detected a train and it's waiting for the second sensor to trigger. If I re-trigger this first one, nothing happens. But if I trigger the second one, now it knows that it updated the speed here on the screen, and that's how fast it goes. If I trigger them in the opposite direction, you trigger this one first and trigger that one second, right? It works in either direction with this setup. Now, if you notice, if I trigger that one and I wait, and I think the timeout's about 57 seconds, so you could adjust that in the sketch to timeout. it doesn't lock up. It won't lock until, it's kind of locked. It sets a flag and it locks the detection, waiting for the second sensor. But if the second sensor doesn't detect anything after 57 seconds, it'll time out and return a value of like 1 mile an hour or whatever it is. But it will unlock itself and go back to detecting. Should hear timeout any second. Come on. But it gives you a visual indication. There, finally timed out. So it's going 0.31 miles an hour. So if your train can't make it through if it's creeping that slow, you've done a great job of getting a smooth runner. The other thing is, so when I trigger this and trigger the second one, it will not let me re-trigger. You see the lights out except for that one power light. As soon as this flasher starts coming back on, that means it's available for another train to come through. So being that I'm going to set this up on a loop of track, it will allow me to sense, it's got to go around the loop, and I can just keep coming past it and do programming on the main and adjust my CV5 for the top speed, and then adjust CV6 for my mid speed. I'll post another video on the sketch for this little nano circuit because I'm only using 3 pins on the nano. So I've got 1 pin for each sensor. That's it's on this side. These two, pins 6 and 7, and then 1 pin that runs off to the Arduino Mega that's actually detecting and putting the inputs into JMRI for the speedometer. And right now I'm working in Fusion 360 to CAD up a little building that these will go into with the Uno. And basically you bring in 5 volts DC, will power both of these sensors, the Nano, and you'll have it's a 40 by 60 foot station structure that I'm going to mount on my little programming track setup, just for housing it and not having wires going everywhere. But that's what we've been working on, and I think it works pretty well. There's enough pins on the little Nano that I might be able to add a script for doing PWM crossing gate flasher, and I think this will have enough current sinking capacity to be able to drive a crossing flasher, and won't have enough to do servos, but we'll maybe rig that SketchUp all into this so that we're using a few more pins, and it'll be kind of cool. So that's what we've been working on. We'll talk to you next time. Hey there, back again. Just realized that you couldn't see what I was doing in the last recording, so I wanted to add this little bit. So I was going to show you how to set up the sensors for the speedometer. So let me get the sensor screen up here. So File, Open Panel Pro, Tools, Tables, Sensors. And let me move this screen down here so you can see what's going on. So right now I've got 2 sensors. These are pins on the Arduino Mega, the base unit. They're set up in DCC++. Right now I've got it looking at all, but that's the only two sensors I have. The inputs are inverted because the sensors signal active high, but the inputs on the Arduino Mega expect active low. So we invert the inputs. If I edit this, you can see that the properties, it's a sensor pin, it's pin 22. I set the pull-up to true, so it's got a pull-up resistor on it, and our ID is set to 1, which the basic, you could add other names or whatever, and here you can set inverted. I don't have any debounce, I don't have any pull-up, pull-down, don't have anything in the other ones. This other pin, which is what I would use if I wanted to use these two sensors as inputs straight into the Arduino Mega, which you could do and set it up as sensor 1 and sensor 2 in this speedometer page. Just have to rewire it a little bit, but I wanted it to sense in both directions without having two speedometer windows. So if I go window, speedometer, there, bring up the speedometer. Now normally this is all cleared out, but basically you set which sensor you want to use. Sensor 1 starts on entry, sensor 1 stops on exit, and we're not using timer 2. Got our feet. We can start this, and I save this as the default, so every time I open the speedometer window I don't have to retype in the values. Hit start, and it's ready to go. You can work out your scale feet. Now for HO you probably want to change this and maybe separate the two sensors a little further. So if we wanted to do this for HO scale, we put in 13.3 scale feet, and we're going to start it, and let's see how fast we can get it to go with just waving my finger in front of it. So 431 miles an hour. If I drive at a normal speed, wait for it to re-trigger, 41. Works fine. So even if you wanted to do a smaller structure, like a scale house or something like that, you could get away measuring some decent speeds in a very short distance, even in HO scale. Maybe if you wanted to do G or O, you might need to spread them out a little bit, but depends on what kind of speeds you want to run. I don't run my locomotives any faster than 66 miles an hour. That's the top speed for any of mine. But, you know, you can adjust this. You can make it do whatever you want. And I think it'll be a pretty flexible system once we get it all set up. Thanks. Thanks for watching.